liquid, that is a liquid, and second is a gaseous. Liquid is to be considered as an incompressible fluid. It's considered as an incompressible fluid. Incompressible fluid. Whereas gaseous is considered as a compressible fluid. Compressible fluid. Gaseous is to be considered as a compressible fluid. Okay. What is the difference between the incompressible fluid and compressible fluid? That first we discuss what is the mass density. It is mass density, or it is also called as simply a density. Mass density, or simply density. Mass density or density of the fluid. It is a ratio of. It is a ratio of mass of fluid, mass of fluid, mass of fluid to its volume. To its volume is called mass density. Mass density, or simply density, or simply density. It is denoted by a Greek letter, that is rho. Rho. Symbol of density is a rho, denoted by rho. It also defined as mass per unit volume. Mass per unit volume is called density. Is called density. Is called density. Okay. So the rho is equals to mass of the fluid. Mass of fluid to its volume. To its volume is equals to mass divided by volume. What is unit of this? Unit, that is unit of mass is kg per meter cube in a SI unit system. In CGS unit system, gram per centimeter cube. Okay, this is dimension. What is dimension for this? Dimension for density. Dimension for density, mass 1, n raised to minus 3, t raised to 0. This is dimension. Okay. Density is also called as a mass density. For example, if you consider some standard the example here, what is density of water? Density of water is considered as the density of water. It is 1000 kg per meter cube. And density of mercury, Hg, it is taken as 30,600 kg per meter cube. Okay, it means that density of mercury is higher than the water. Next definition of the fluid: specific weight or weight density is properties of fluid, denoted by a letter W. Specific weight or weight density. Specific weight or weight density. It is defined as the weight per unit volume is nothing but the weight density. Weight per unit volume. That is a ratio of. It is a ratio between weight of fluid, weight of fluid to its volume is called as a weight density or specific weight. Thus, weight per unit volume, thus weight per unit volume, weight per unit volume of fluid is called weight density. is called weight density. Mathematically, it can be written as weight of fluid, weight of fluid to its volume of fluid, volume of fluid, weight of fluid to its volume of fluid. And what is weight? It is mass into acceleration divided by volume. You can write mass by V into Z. Therefore, weight density is equals to rho into Z. It is nothing but a weight density. Nothing but it is a weight density. What is unit of weight density? What is unit? The unit of weight density, unit, unit, Newton per meter cube per centimeter square, centimeter cube. Okay, it's nothing but a weight density. What is the weight density of water? Is equals to, what is the density of water? 1000 into value of z, acceleration due to gravity, 9.81. This become 9810 Newton per meter cube. It is weight density of water. Okay. Next property, specific volume. Next property, specific volume. The volume per unit mass, the volume per unit mass is called specific volume, is called specific volume, is called specific volume. Okay. Specific volume is denoted by letter nu. This nu is equals to volume per unit mass. It is mass. Volume is nothing but V. Mass is a M. What is this? Then we can write 1 by M by V. So 1 upon rho. Specific volume is a reciprocal of density. Therefore, nu is equals to 1 upon rho. Specific volume is a reciprocal of density. It is a reciprocal of density. It is a reciprocal of density. Okay. Reciprocal volume is a reciprocal of density. Okay. Unit is meter cube per kg. Meter cube per kg. Next, specific gravity or relative density. Specific gravity or relative density is denoted by letter SPA dot CRA, specific gravity, or simply by a letter capital S, by letter capital S. Okay. Here, specific gravity, how the definition of specific gravity? It is defined as specific gravity. It is also called as a relative density. It is also called as a relative density. Ratio of, ratio of, it is a ratio of weight, weight density, or simply density of any fluid, of any fluid to the weight density, or simply density of standard fluid, of standard. Okay, it is called as specific gravity. It is called as a specific gravity. Therefore, mathematically you can write specific gravity is equals to the weight density or simply density divided by of any fluid to the weight density or density of standard fluid. We consider here standard fluid. What is standard fluid? Okay, for liquid, standard fluid is taken as a water, and for gases, standard fluid is taken as a air. Okay, these are the standard fluids. So we assume this standard fluids. Okay. So, what is density? That is, what is the specific gravity? The specific gravity, it is write in this way. Specific the density of any fluid, and right here, the density of a fluid, rho of any fluid is given by specific gravity into rho of H2O, the standard fluid. Standard fluid is water, so the density of water is 1000 kg per meter cube. Okay, so this rho f is nothing but what is specific gravity of given fluid into density of water 1000. Usually assume the density of water is 1000. This is your formula. It is dimensionless term because it is the ratio of the same quantity. Viscosity, Newton's law of viscosity. How to define the viscosity? Okay, viscosity. First of all, you discuss the definition of viscosity. Definition. How to define the viscosity? That is, it is properties of fluid. It is property of fluid which offer resistance which offer resistance to the moment of one layer of fluid to the moment of one layer of the fluid over another adjacent layer of fluid is called as a viscosity. Is called as a viscosity. We draw here a diagram. That is on the x-axis we take the velocity, on y-axis we take the distance, and we can draw here parabolic shape, the velocity profile of the liquid looking like this. The velocity profile, this parabolic velocity profile. As a this is a fixed plate. This is what? A fixed plate. Okay, and that is this is what velocity profile. Velocity profile. Okay, let us consider the first layer of the fluid moves with a velocity that is u. Okay, it moves with velocity u. The second layer of the fluid moves with the velocity u plus du, and the distance between these two layers is a dy, and the difference in this velocity is a du. Okay, that distance is okay. See here, this is one layer. This is a layer number one. This is a layer number two. Well, the two layer of the fluid at distance dy apart, one move over the another at different velocities. The velocities of the layer 1 is u, the velocities of layer 2 is u plus dv, that is shown in figure. This is the top layer causes shear stress on adjacent lower layer, or lower layer causes shear stress on the upper layer. This shear stress is proportional to this shear stress is proportional to rate of shear strain, that is a du by dy, that is called as a shear strain. That is tau is directly proportional to du by dy, and tau is nothing but a shear stress, is nothing but a tau, and this is called as a rate of shear strain, rate of shear strain, rate of shear strain, rate of shear strain, is nothing but a rate of shear strain. So one can write tau is equals to mu into du by dy, mu, where mu is called as a coefficient of dynamic viscosity, where mu is called as a coefficient of coefficient of dynamic coefficient of dynamic viscosity, dynamic viscosity, dynamic viscosity. Okay. Next, what is dynamic viscosity? Dynamic viscosity, how to define by Newton's law of viscosity, by Newton's law of viscosity, by Newton's law of viscosity, Newton's law of viscosity, Newton's law of viscosity. That is tau is directly proportional to du by dy. The tau, or this can be written as tau is equals to mu into by dy, where mu is called as a coefficient of dynamic viscosity, or simply dynamic viscosity, where mu is called as a dynamic viscosity, dynamic viscosity. So the mu is nothing but a tau divided by du by dy, du by dy. Okay, the unit of this mu is nothing but, what is the unit of mu? The unit of mu, that is mu, unit of mu is nothing but a Newton second per meter square, Newton second per meter square, as we know that Newton per meter square is equals to Pascal, Pascal, as 1 Newton per 1 Pascal. Therefore, this unit of viscosity becomes Pascal second. Okay. Again, the physics unit of this viscosity is called as a poise. One poise is equals to 1 by 10 Newton second per meter square. Okay, this is nothing but a dynamic viscosity. Next is kinematic viscosity. Kinematic viscosity. How to define this kinematic viscosity? Definition of kinematic viscosity. That is a ratio of, it is a ratio of dynamic viscosity, dynamic viscosity and density, dynamic viscosity and density, that is called as a dynamic viscosity. That is nu, denoted by the nu, that is dynamic, nu by rho, dynamic viscosity per unit density, that is called as a kinematic viscosity, kinematic viscosity. Okay, this is kinematic viscosity. What is unit of kinematic viscosity? The unit is nothing but a meter square